Hey, calculus multivariable friends, how we doing? It is time to start our review of challenging, rewarding, I'm not going to say difficult, but rewarding advanced integration techniques that you're going to definitely need to know very well next year when you continue on at the college of your choice. This is now loaded up on Canvas, so you should have access to these notes. I'm not going to do every single problem because what you'll notice is I've also posted a corresponding worksheet, so there isn't any book problems. If you want to look in your book for problems, they're certainly there. Also, I've got answer keys to both the notes pages for examples that I don't do, as well as all the homework problems. So there's a two-page homework problem that we're doing. So what I'm going to do is kind of break this up. Lesson one day, practice the next day. Lesson one day, practice the next day. So tomorrow's assignment won't be a video. You'll have those corresponding practice problems for integration by parts with answer keys. So it's all there. It's all available to you. So do as much as you can. We're now being asked to have a daily grade each week. So I probably will have a quiz at the end of this week just on the new topics that will have discussed. So that'll be integration by parts is what we're doing today. And I'll probably include integration of powers of sines and cosines. So that'll be tomorrow's lesson and some practice, and then a little quiz on Friday just to keep us on track. I think if we nibble away at these little quizzes, we'll make sure that everybody's engaged instead of trying to panic at the very end and learn all the topics. So a little bit at a time should do it. Let's do this. I like this derivation of integration by parts. If you want to read this example why you would need integration by parts, feel free. But integration by parts all starts with the chain rules, why we need to do that. So reordering this, it derives it out, is the integration of u times v equals uv minus the integral of v du. So that's when and it all results from the product rule where we've got a product. Before we were able to manage products when we had the du included the parts that were multiplied. So it had to do with the chain rule. You were looking for the inside function. You picked that to be u. You made up du, and it also had, let's say our du had the other parts of the product in there. That's not going to work with things like this. So we'll kind of do some examples here. So, and there's our chain rule again. Not sure how that's any different than this, so just as a reminder. Okay, so this first one, we've got cosine x times x, and we're going to go ahead and set this up for integration by parts. You always want three pieces of information that you're going to place in the u and the dv. You've got x, we've got cosine x and dx. Well, the dx is going to always go in the dv slot because you're going to take the integral there. But what would you pick for your dv slot? And we'll talk at the end of the lesson on ways to pick u. It's kind of an easy way to picture those, but we've got that. So they've got this completing the chart here. So you've got this u equals x, v equals sine of x, because dv is what you're picking here. So you're saying u equals x, dv is what's left, cosine x dx. I'm going to take the integral of that to work up. I'm going to take the derivative of that to work down. So the derivative of x is 1, but it's dx because it's a differential really. And then the integral of that, well, what's the antiderivative of cosine? Somebody took, is it positive sine? The answer is yes, positive sine. Okay? So we're plugging things in, and you've got this here. So the integral of uv, udv equals uv, you've got u times v, minus the integral of v du, so sine x dx. So what we've done is create another integral that you can take its integral of, work it down, and then the antiderivative of sine is actually negative cosine, so that makes it a plus. Lots of places to make silly mistakes. And I like this reminder. We sometimes forget this. Check it out, take the derivative of that, and see if you get back to your original problem. So you'd get that one there. Okay, so you can take that derivative of that. All right, so let's try this one together now. U is going to be x okay? Because, well, and again, you might have to experiment, you might have to play, that's okay. And dv then is e to the x dx. Usually when we pick u, we want to pick u so that the derivative of u is going to make it simpler. I've got either x or e to the x. Well, the derivative of e to the x is not getting any simpler at all. So the derivative of u, if it's x, is going to be just dx there. And dv then would be, well, e to the x, it's our friend there. So you've got u integral of x e to the x dx equals uv, so u times v, x e to the x, minus the integral of what? U of v du, e to the x dx, e to the x dx. So integral, again, uv minus v du. Integral of u dv equals uv minus integral v du. Okay? Well, we can do this antiderivative. Isn't that just going to be x e to the x? We've got that. Minus e to the x plus c. Okay? Now, this time they say to do the definite integral from 0 to 1. That's a good reminder because we've already done that antiderivative. So we can go that, e to the x dx. Right? So I've got that. I don't have to worry about plus c, but I am going to say, well, I'm going to say x e to the x minus e to the x. So all of this that we did before still applies, but then I'm going to evaluate that from 0 to 1. Okay? So plug in a 1 and plug in a 0. So you'd have 1 times e to the 1, right? Right, so that'd be e minus e to the 1, which is e, minus 0 there, because you got 0 times e to the 0, which is 1, so 0 times 1 is 0, minus, be careful, that's not e to the, well, it is e to the 0, it's not minus 0, it's e to the 0, which is minus 1. So e minus 0 minus 1 equals positive 1. So believe it or not, the area under that curve, crazy enough, is just 1. Okay? This next one is also a good one. I've got x squared or I've got log of x. Well, which one of those can we take the antiderivative of? Okay, because usually we've been picking x as our u. I don't know the integral of log, do you? In fact, we don't. We'd have to use integration by parts to derive it. So we're going to say this one is u is our log of x there. That means that dv is what's left. X squared dx. Increase the power, divide by the power, x to the third over 3. And I can take the derivative of log of x easy enough. That's 1 over x dx. Okay, so change it up a little bit because all along we've said, oh yeah, u equals x squared or u equals x or whatever. We don't know the antiderivative of that one, so we're stuck with picking this one instead. So let's write that out. U dv, right? The integral of that is uv. So we've got uv, x to the third over 3 times the log of x minus the integral of v du. Well, minus the integral of v du, aren't one of my x's going to divide out there? So I'd have 1/3 x squared dx. 1/3 x squared dx. X to the third over 3 log of x minus, what's the antiderivative of that? Well, that'd be 1/9 x to the third plus c. Alrighty? So change in our strategy there. And again, when you're first learning this, I hope you kind of approached it as a puzzle. And okay, well, if that didn't work, try another part. If that didn't work, try another part. Okay? Well, here we are. In fact, this one has a typo here. U is not e to the x. Okay? U is not e to the x. We've got the integral of log of x. Remember I said we'd have to integrate this. U is not e to the x. U is log of x. dv is what's left. Well, I've already got that. So dv is not x dx. Cross that out too. It's just x. So dv equals dx. Take the antiderivative of dx, you get x. Take the derivative of log of x, you get 1 over x dx. 1 over x dx. Okay? So u equals log of x. dv is what's left. So that's all we've got. We've got those two parts. So not a very exciting dv, but it is what it is. We can take our antiderivative now of log of x, and we get what? uv, so u times v, x log x, minus what? The integral of v du. Well, look what happens to your v and your du. The x and 1 over x divide out. You just have integral of dx. We can do that. X log x minus x, right? Because the antiderivative of dx plus c. All right? Now, when things go wrong, okay, it's like sometimes it takes a little practice here. Integration by parts trades one integral for another. You're still having to do an integral there, okay? The bargain is worth making. Okay, it sounds a little dramatic there. But if your second expression is easier to integrate than the original one, if the second one isn't any easier, you're kind of stuck, okay? So, for example, in example 2, suppose x times e to the x, you set up your chart like this. U equals e to the x, that would mean du is e to the x dx. X is e to, or sorry, dv is going to be dx. So you've got, we picked this one instead. What would that give us? Well, it'd be 1/2 x squared for your v there. Does that set it up? Well, let's see what we've got then. The integral of e to the x times e to the x, sorry, x times e to the x dx. Using this table here, it'd be uv, so we've got what? 1/2 x squared e to the x minus the integral of v du. 1/2 x squared e to the x dx. And hopefully you're scratching your head, well, that's not any better. So back to the drawing board, okay? So that was wrong, so you just have to work it out, okay? Work it out there. Same idea here. And it wasn't wrong, well, it just didn't help, so, you know, we're stuck. You know, that's, sometimes that's going to be the case. You've got two possibilities. Well, I'll get you started on this. You could say u is e to the x, so that would mean that dv would be 2x dx. That gives us v is x squared, and du is e to the x. Oh, sorry, this is e to the x squared, sorry. E to the x squared times 2x. It's like, ooh, well, maybe that's not so hot. That might look a little messy. What if you just said, try good old u substitution, right? So u, in this case, don't do u dv. Sometimes seeing that, oh wait, 2x is my du for that x squared. So don't always just, oh yeah, I'm a robot, I'm going to take the integral, I'm going to use integration by parts. Instead, think about what you've got. This isn't a good strategy at all. So hopefully you can, in fact, that's what our problem is, that just good old u substitution. Try it. I'll let the reader do that. Okay? So here's another one. I haven't taught you the integral of arctan, have I? That's because we don't need it, okay? We don't need it because we can use u substitution to get it, all right? So if u is inverse tan or arctan, I can take the derivative of that. Yes, you would need to still know the derivative. That's 1 over 1 plus x squared for arctan of x. 1 over 1 plus x squared. dv, well, what's left? dv is going to be dx, so you've got v would just be x. Integral of arctan then of x dx equals uv, so uv, x, arctan x, minus the integral of v du, x over 1 plus x squared, dx. Well, that sure looks a lot like a log pattern, doesn't it? If I had a 2 here and a 1/2, I'd have du over u, wouldn't I? 1 plus, yeah, I do. Minus 1/2. So that's all equal to x arc tan x minus 1/2 natural log absolute value 1 plus x squared plus c. So I like this unit because it's getting us back into integrals and setting things up. Okay? We'll do this next example because you'll see that we might have to try it again. Okay? So u, I think we would all pick u equals x squared because taking the antiderivative of e to the x is the same as taking the derivative. So dv then is going to be e to the x dx. V then is x e to the x. This is 2x. Okay? So setting that up, we've got this uv x squared e to the x minus the integral of v du. Oh wait, I need a dx here too. Minus 2x e to the x dx. Huh, do we have to keep going? What's our answer? Well, can I do integration by parts again? The answer is yes. Doesn't continue on, so we'll just go ahead and finish it here. U now equals 2x. V is still going to be e to the x, so dv was e to the x. And if I take the derivative of that, I'd have 2 dx. So we'd still have to remember our x squared e to the x term there, minus that whole thing. So minus what? uv 2x e to the x minus the integral of v du. V du, whoops, this is 2 dx, sorry, not 2x dx, but 2 dx. So uv, 2x e to the x, that part's right, minus 2 e to the x dx. Well, we can do that. X squared e to the x minus 2x e to the x. And then what do we have here? Well, minus, right? Minus, we're distributing that. That 2 is just going to be a constant. 2 e to the x plus c. Alrighty? Any questions so far, please direct those to my email or leave a comment on video or whatever. But I'm hoping this is all review. This should be review. We learned this in BC last year. This next one, I'm going to call it a little circular because you'll see why in a second. You've got e to the x and sine x here. I'm going to pick sine, actually, for my u. And that means I'm left with e to the x dx. You're saying, well, how did you know to pick sine for u? Well, let's just kind of see. It takes a little practice here. And instead of this example 9 tougher one, I'm going to show you how I picked that one using a mnemonic that should help you remember that. The antiderivative of sine is cosine. The antiderivative, I misspoke, didn't I? The derivative of sine is cosine, right? Because this is u, so I've got a du, so I apologize. The derivative of sine is positive cosine. The antiderivative of the x is just e to the x. It's our good old favorite there, okay? So we've got e to the x, so uv, e to the x dx, right, what we've got so far, sine x, e to the x, minus the integral of what? E to the x cosine x dx. Well, I've got another hard one to do. It's like, ugly. Okay? So I'm going to pick the same type of function. This sine x e to the x, I'm good with that. But I'm going to say u now equals cosine x. Du is negative sine x dx. Dv is e to the x dx. And good old e to the x is our surviving here. So I'm going to tell us, in fact, I might run out of room. Let me just slip in a piece of paper here because I want to make sure that everybody can see what's happening here. So I'm going to put this in here so I don't have to write super tiny here. There we go, that'll work. So I've got what? The integral of e to the x sine x dx. I'm going up with our original function here. Is that minus this? I'm going to use substitution, or parts again. Sine x times e to the x minus, okay, minus the whole thing here. So my uv minus e to u now, minus e to the x cosine x. Okay. In fact, I could have, I don't know why I wrote sine first. Minus the integral of e to the x, right, times v du. E to the x sine x, there it is, dx. All right? If you look at that, that's the same as what I have there. So I could add this over here and say 2 integrals of e to the x sine x equals e to the x sine x minus e to the x cosine x. Well, if that's true, divide all of that by 2. Couldn't we say the integral of e to the x sine x dx equals 1/2 of this, e to the x sine x minus e to the x cosine x. And don't forget plus c. You want to have a plus c at the very end. Okay? Questions there? Questions there? Okay. All right. I'm going to leave these last 2 examples as tougher one. The link has the answers to those, so you can walk through those. Because I want to stress, because I'm kind of up to my time limit, I'm trying to set these up about 20-25 minutes, is how to choose u. Because you got a u and a dv. And either LIATE or ILATE. Okay, liate is how I learned it, and I think that's how your book calls it. But ILATE kind of ties in with some of us, especially first period. Love you, mean it, but some of you are perennially tardy. Now that you've got it at your own pace, you can schedule this whenever you want to watch this video, so that's kind of cool. ILATE, the good news is I and L aren't going to be competing each other as we choose, but you might see where I'm going with this, and hopefully your teacher showed you this last year. The L in liate or ILATE stands for logarithmic. If you have a logarithmic part in your u or dv, you're going to pick the logarithmic function as u, because you can take the derivative of a log function. You can't take the derivative of a, or antiderivative. You can't take the integral of a log function. I stands for inverse trig, and we did one example with that with the arctan function. A is right in the middle, and you've seen that before. That would be an algebraic function. So polynomial function, x to the third, x squared, whatever. Okay, that's nice in the middle. Sometimes it's going to be u, sometimes it's not. T would be plain old trig function, because the derivative of a trig function gives you another trig function. It doesn't get any easier. And the e, I bet you all remember this, is exponential. It doesn't ever get any easier. In fact, it doesn't change. E to the x, the derivative of that is e to the x, integral of that is e to the x. You're never going to pick u for your exponential function. Okay, so keep those in mind, and I'll let you do examples 8 and 9, but the work is all in the notes page. All right, so what you'll have now is in your Canvas course chances to do some practice problems, so you'll see those in there as well. All right. If you have any questions, like I said, please email me. I'm hoping everybody's doing well, and have a good one. And most of you have wrapped up on the test. That was good. I'll be putting those test grades in here pretty soon. Have a good day, and I will talk to you soon.